Okay, so the part of the chapter that took up the biggest chunk of time was us simplifying. So this was, I believe, section 2, which was simplifying radical and power expressions. Okay? By the end of the section, your goal was to be able to do something like this. Simplify something like this down as much as possible. Okay? Or another example would be simplify this expression down as much as possible. Okay? That was the objective of the whole section. Okay? So I'm just going to run through a bunch of examples for you of stuff that you might see to be able to help you out as much as possible. Your goal is to try the problems yourself before seeing how they're acted out. Okay? I'm going to run through a bunch of examples. Okay? But your goal is to try them yourself first before you see how I do them. Okay? So let's say I start you off with something like this. I'm going to ask you to simplify this radical expression. Okay? Let's say I've got 8x to the 4th, y to the 5th, z. Okay? 8x to the 4th, y to the 5th, z. And my index on my radical is 3. Your goal is to break up these terms somehow into powers of 3. Okay? So this 3 corresponds to what I want on the inside. Okay? 8 can be broken up as 2 cubed. That's fantastic, right? We need powers of 3. X to the 4th can be written as x to the 3rd times x, okay? Because we know that if we multiply two things with the same base, they add their powers. Same thing with y. I could take y to the 5th and break it up into y cubed, y squared. Z, I have to leave alone because it's only to the first power. Okay? When I'm given a radical expression and I need to simplify it, I need to keep it in radical form. Okay? I can't do powers. Okay? So what I'm going to do, I'm going to replace all of these things in my original radical. I've got the cubed root. 8 is the same thing as 2 cubed. X to the 4th is the same thing as x to the 3rd x. Y to the 5th is the same thing as y to the 3rd y squared. And z I'm leaving alone. Okay? Anything that has a power of 3 gets pulled out. Okay? So in a sense, what I'm doing is I'm looking through and seeing which ones have powers of 3, and I'm going to write them on the outside. Okay? When I write them, I'm going to cancel them out. Okay? I'm taking the cubed root of those. Oh, but this isn't, you can't see this. Hold on. So what I'm doing is I'm taking the cubes and I'm pulling them out. So I have a 2 cubed, I have an x cubed, and I have a y cubed. Okay? That's canceling each one out. I'm cube rooting those. Okay? Anything else that I didn't cube root is the leftovers. Okay? That's what's left over inside the radical. So I have x left over, I've got y squared left over, and I have z left over. That is my simplified expression. Okay? 2xy times the cubed root of x, y squared, z. Okay? What was my process? Take everything that's inside and break it up as much as I can. Okay? We're looking for powers of 3. Rewrite what's inside as all of those things that I broke it up into. And then anything that has a 3rd power, put it out front because I'm taking the cube root of it. Okay? And then the leftover stuff gets left in the radical. All right, let's go through another example of a radical one. I've got the 4th root. Let's do something like x to the 8th, y squared, z to the 4th. Okay, I've only got variables in here, so that's fine. Okay. My goal, rewrite everything in terms of the 4th power, okay, because we're taking the 4th root. Okay, x to the 8th is the same thing as x to the 4th, x to the 4th. Okay, y squared, I can't break that up into powers of 4. Z to the 4th is already as a power of 4. So the only thing I need to make a substitution for is the x. I'm going to rewrite this. The 4th root x to the 8th is x to the 4th, x to the 4th, y squared z to the 4th. Now what I'm going to do, anything that has a 4th power, I bring it out front. I've got x to the 4th as a power. I've got x to the 4th as a 4th power. I've got y squared, that's a 2. Z as a 4th power, so I'm bringing a z out too. Okay, so I did one of the x's, I did z. So the only thing that I'm left with is y squared. And in fact, you'll multiply these together now to get x squared z, 4 through y squared. That's how you would simplify that. Okay, an example of one that's a multiple of the index. 8 is a multiple of 4, so we have to do an additional step by multiplying it out in the end. Okay, let's do one more with a number in it. Let's do the square root of something like 45. Okay, square root of 45, x to the 3rd, y to the 5th, z squared. Okay, so I've got a index of 2 and I've got powers inside that are odd. Okay, and that's fine, we can deal with that. But we've got a 45 in here. Okay, whenever you have a number that you can't initially take the root of, in this case I'm looking for the square root. I'm going to get rid of that 2 because that's an implied 2. I can't take the square root of 45 directly. But what I do know is 45 can be written as two things. 9 times 5. Okay? And this corresponds to 3 squared. Okay? So if I have 9 being 3 squared, I've got 5 right here. This corresponds to 45. So 45 is the same thing as 3 squared times 5. Keep that in mind. Okay, so I've got this. I'm going to go through each of the letters now too. X cubed, I'm looking to make it into something that has x squared in it. So that can be x squared x. Y to the 5th, I can make into y squared y, or y to the 4th y. It's the same thing. Z squared, I can make, well, z squared is already squared, so I don't even need to change it into anything. So now what I'm going to do, I'm going to change this expression to match up with what I have these corresponding to now. Okay, so I'm going to have my square root. 45 is 3 squared times 5. X cubed is x squared x. Y to the 5th is y squared y. And z squared we're leaving alone. Anything that I take the square of, I'm going to underline. I'm going to square root those. Okay, so in a sense, I square root the 3 squared, so I bring the 3 out front. I square root the x squared, so I bring an x out. I square root the y squared, I get a y out. I square root the other y squared, I get another y. I square root the z squared, I get z outside. What all is left inside? I have a 5 in there, I've got an x in there, and I have a y in there. Okay. In fact, this ends up. Oh, we cannot see that. Okay. Let me rewrite this up here. So what I have on the bottom is I have 3x y y z square root 5x y. Notice that I took the square root of the 3 squared, the x squared, the 2y squareds, and the z squared. That's how I got where I'm at up here. Okay, the leftover stuff, the 5, the x, and the y are still inside that radical. Okay, I'll just combine stuff now to make it look nicer. 3xy squared z times the square root of 5xy. That's how I would simplify that radical expression. Okay, no dealing with fractional powers, just all straight radical stuff. Okay, so if you have a number in here, and you can't take the square root of it, you need to break it up into something that you can take the square root of. Okay? It's going to look something like this. One of the numbers you won't be able to square root, the other one you might be able to. So that's how we're able to simplify it down further.